There is a follow-up video on design of experiment. We are going to look out some more example on design of experiment. And the examples directly coming from the Minitab samples. We are going to explore out and learn much more details about design of experiment. In detail, we're going to learn it. For example, we are going to learn response optimizer and cube and all that different type of experiments within the design of experiment. We are going to learn it. This is a case study which is given directly in a Minitab. We're going to unfold one, and I have just in the interest of for the better readability, I have just put this up here. A building material manufacturer is developing a new insulation product for construction. They would like to study four variables that are believed to impact the three quality characteristics, right? And the insulation value, density, and strength. These are called responses. And the four variables or in other word, a factor are material type, injection temperature, injection pressure, and cooling temperature. They also recorded the temperature at the time of the density measurement. So density measurement we are going to look at, which is included as a covariant in the model for density and strength. And this is this is sample. We're going to go with this insulation 2.mtw. I open the Minitab, go to file and open the open worksheet. And you can go to insulation, type insulation. And we're going to look out insulation 2, right? Open that. As you can see here, everything is given here. The standard order, run order, center point, and blocks. If it is not there, let me tell you how to be created. Okay, anyway, it is already given. So there are 16 runs being done, and the material type is there are two level are there. One is Formula 1 and Formula 2. This is a repeated. And injection, you have a minimum is injected value is 75. Another one is 150. Again, two levels we have. Another one is injection temperature 85 and 100 we have. Another one is that cooling temperature is being kept 25 and 45. That means all these are called, this is factor 1 and this is factor 2, and then you have a factor 3 cooling temperature, and then measurement temperature you have, sorry, this is also a factor, right? So there are four factors are there. You may call it as 1 2 3 or anything, so I'm just giving the name of four. That means four factors we have. Factors, another word is called independent, right? They're independent. You can change it, you can categorize it, you can bring the category. These are all responses, as you can see here. A measurement temperature is a response, insulation, density, and strength, right? And now in the questions, as you can see here, let me go back to the question. So three quality of interest, insulative value, insulation density, and this one, and there are four variables: material type, insulation, and injection temperature, injection pressure, and cooling temperature. This is what we have seen here, right? And now we will see how further we can do, right? And what okay, now the formula is minimum run, how we need to have R equal to L the power of F, right? How many levels we have? We have two level. How many factors we have? We have four factors, namely material, injection pressure, injection temperature, cooling temperature. That means we need to have minimum 16 run, right? 2 twos are 4, 4 twos are 8, 8 twos are 16. That means minimum we need to have 16. So now we have got 16 material here. This is good to see, right? Further, what we can do, and let me clear this one, and let's go and do that. So as I said, that the standard order, run order, center point, and block point, we can also create. So go to this design of experiment and you have a factorial and define custom. First you define it, although the standard error run order is given, but you can define it. If you wanted to know more about standard error run order, center point, and blocks, you can follow my previous video, right? And now we are going to talk about the the factors. So the factors starting from material type all the way to all the way to cooling temperature. So that means four are the factors, right? And then you can see here formula 1, formula 2, this is given 75 and 150, 185 and 100. This is perfect uncoded because we have formula and formula 2. Otherwise, it could have been coded. Okay, this is uncoded is perfectly fine. Give okay design. You can see here we have already given a here. We can just put that values also here. Standard order in that one run order, and then you have a center point blocks. You can give blocks. Give okay. Give okay. This is done. So that means the planning part is done. Go to stat again, design of experiment. Now factorial. Now this part is done, right? Now what we have to do? We have to do analyze. Analyze which are all the responses. Insulation is a response for us, and density, strength are the responses for us, including the temperature, right? So all four are responses. And machine, you have one and two. That would be a factor just for reference purpose. Give okay. Now we got it. Okay. So now we got that response also for this. So how we did it? So we did for four. And you can give stepwise if you wanted to reduce it to some step forward or backward, you can do it. But generally stepwise is also good. So you can give okay, you can give okay. So it has given for all the factors. So material and is important A, B, C, D. All these are significant factor, right? And so we have similarly we have got this for density, and even for the other one. This is also important. Insulation also, all the four factor are important. And similarly, this is for the measurement temperature. Only A is important, right? And our other things are confounded. So this is only this thing. And then you can see here strength. Strength, these are the one which is important factor. Almost all the one A, B, C, D. C, D is confounded, and A, B, D is confounded, and this is the one. Now let's go further. Now in the question what they have asked is they also recorded the temperature at the time of density measurement, which is included in the covariant in the model for density and strength, right? And so they believe that impact three quality characteristic: insulation, density, strength, right? Insulation, density, and strength. Okay, let's go further. What you can do, go to stat and design of experiment, factorial, and now you have a lot of options. Like you can do predict, you can do factorial plot, you can do cube plot, you can do contour plot, surface plot, overlaid, and all that. First, we'll go to the response optimizer. So let's say strength. So strength, and we have to maximize it as density. Let's say we will have to, as per the requirement, we have to maximize it. Insulation, again, maximize it. Temperature, keep it as low as possible, right? Let's say if the requirement is different or you have any target value, you can keep it. So give okay. Now you can see that nicely it has the response optimizer is ready now. Okay, graph. Okay, so yeah, so it is ready now. Yeah. As you can see here, the if you want the setting to be like that, you have to keep in formula 2, and injection pressure should be 150 and 100 and 45. The best thing about this one is that even when you move, right, you can see that if let's say you're moving to formula 1, what will happen? Everything you can easily detect it. I have undone that. So strength, this is what we are going to get it, the maximum 37, and density and insulation and so on. This is what the nicely we can get it. And even if you want, like, as per the product requirement, we need a density which is as minimum as possible. Again, you can just shuffle, the value will change. Eventually the value will change. So density, the minimum value we're gonna have, and then this is the value we're getting it, right? And let's say we will go to the next one. I think this is more enough. But if you wanted to see another plots, you can also do that. How to do that? So you can go to overlaid contour plot. Let's say you wanted to, because in the question they have asked only to study the material three one, right? Insulation, density, and strength. Insulation, density, and strength. So we're gonna lay out the other one. Okay, density and insulation. These three, right? As per this one. And you can give this one, can give okay. And you can again, what is the strength value we need to have? You can also record it, right? So you can see strength, the maximum is 37, right? Let's say we want only 30, 40, between 30 to 40. And let's say density, you can see here 1. Maximum is, let's say, 1.1. And maybe we can want to put like zero 0.8. Insulation, you can see. So maybe we can put like 30 to 25 example, right? And depending upon the requirement, you can change it also. You can do that. So nicely, this graph also has come up. You can see that injection value, this 3, 1, right? So at the place of injection pressure, injection temperature, and then you have that values also as well, right? So strength, this is a strength, right? So these three things, all three, contour plot is very helpful where we can just study three of the things together. That means if the injection is low, and temperature will be low, and whereas the other one, the strength will be high, right? You can easily see that correlation, right? And let's go to the another one. As you can see that all the options is open for us, right? And now we can go to factorial, and now surface plot also you can do. Let's say one by one also you can do. Let's say we want like first strength, right? You can see the how it is there, how the strength is being, let's say we are taking the focus on strength. With respect to strength, what is the shape you need to have, injection and temperature. And control E, now I'm changing to density is a focus. And now you can see with respect to density, what is the injection pressure and injection temperature. Lastly, I will just change it to insulation. And with respect to insulation, how the values are there, right? So we can easily see what is the value we need to keep and all that. It has given very, very beautiful. And furthermore, you can also do, these are all additional, right? So response optimizer has given every solution to us, but we wanted to do much more. Cube refreshment again, and you can do that here, right? For example, let's say we want strength, and I will deselect the material alone because in the material we don't need to do it, right? So the three characteristic material alone, I will take it out. I will, okay, and I will select all this. You can see here beautifully it has come. Injection one, what is the, if you're keeping it low, what the value you're gonna get it. If you're keeping it like injection 150, we're gonna get it 32 as injection temperature. Cooling temperature, all these X, Y, and Z chart, it has given in the form of cube plot. Cube plot is a very nice example. Let's say furthermore, if you wanted to know more about it, this also, there is another formula also given there. The same exercise, you can find it here. You can do it for materials and so on, right? So you can find it here, more example. The same example of what we are doing it now, right? You can also find it for cube also as well. Let's go to another one, stat. Again, we can go to design of experiment and factorial. And then we have also done response optimizer, overlaid, surface, contour, cube also we have done. And then factorial. Factorial, we have already seen it here, but quickly I will do it. Again, we don't want the material type, and then we can exclude the same thing like this one, you can get it. So this is injection temperature, and we have two factor, right? Two levels, sorry, two levels we have, right? And all these three responses you can easily get to know. And then lastly, we can do the other one also, design of experiment. and you can see that if you wanted to predict the value also, you can do, right? Let's say some values, if you wanted to predict what is the strength value and what the temperature you wanted to keep, the other way also you can do. For example, let's say using the formula 2, we know that formula 2 is better, and injection temperature, I'm going to keep it like 25. And in injection pressure, right? So injection pressure, I'm going to keep it 25. Injection temperature, I'm going to keep it maybe 90. And cooling temperature, I'm going to keep it, okay, maybe cooling temperature, I'm going to keep it like 30. You can see here, we can easily get to know the values also as well. So because I have not considered the mean values and all that, otherwise the value you will get it, right? So similarly, you can find it, same thing, we can do it in Taguchi also as well, right? In Taguchi, again, you have to define it and then you have to do that, right? Response we have done, mixture, and then Taguchi. In Taguchi, what we have to do is that we have to create, sorry, we have to create the design first. Similarly, like what we have done it, and maybe we can quickly do that and define, and the factors are material, injection pressure, and these four are the one. Nice factor, no nice factor, s divided by n, and maybe we can put it like no nice factor. And the best thing about this one, you can easily get to know the Taguchi values also as well. Maybe I'll do, and I'll go back, and you can see here right by column. So signal factor, let's say we don't have anything. If you want, you can also have it like this is done. And then what you can do is start again design of experiment, and we can go to analyze. In the analyze one, let's say responses, we can put all, we can take like machine we can lay out, strength we can lay out, and these three we can take it as per the questions. Only three responses, although there are four responses are there, I will take only three. Give okay. You can see that the how the values are interacted or whether not interacted. This is with the signal ratio, and this is without it. And if the formula one, if you're keeping it low, I mean the value is low, and easily you can see that whether it's correlated or not correlated, parallelism and non-parallelism, you can easily find it out. The other one, you can also get to know the values also as well. I hope you find this video very profound and very helpful. Just to quick recap, design of experiment, and you can go to first factorial. First thing to do is that define. Once you do define, the second step is that analyze the design. Two. After that, these are all called responses, output. You can go for response optimizer. This is a fantastic one. Or overlaid condor plot. This is for 3-1. I mean, three chart XYZ, because we have only three responses, but four were there, but the question was on three. Surface plot, you can do Condor. These are all three metrics, and factorial also we can do, right? We can also predict it also as well, right? And also we did that Taguchi also define, and we can also predict that value also as well, right? Using that, we can also predict that if you have any values, we can put it low, medium, high, and all that, right? So we can easily predict that value also with respect to it. I hope you find it very useful. Please do like, share, subscribe my channel. You have wonderful day ahead.